Hello everybody, this is the next video in the electrodynamics series, and in this video I am going to talk about the product rules. Okay, so we have seen the del operator. Now what we are going to do in this video is trying to analyze some of the properties that this del operator, which can operate in three ways, either by taking the gradient or maybe a divergence or curl. So this operator and these operations have some has some this properties. Okay, so we are going to see these properties. The first and the most important properties is the linearity. Okay, so this del operator is a linear operator. So what is a linear operator? So suppose we have an operator O. If it is a linear, that means if suppose this O operator act on a function, let's say V, and it gives some other function, let's say D. So what is this linear operator means? So instead of this function V, we have a function V plus W, and when it is acting on this, okay, apart from that, there will be some scalar A and B that is multiplied with this function V and W. Okay, so what linear operator means, either we will multiply this function V and W with their corresponding scalar and sum them and then operate them, then we will get an answer. Let's say the answer is D. We will do either this way, or what we can say, that instead of putting the A outside, operating on the V first and then multiply with A and then sum their result with the B and operating with the W. In same way, in this way, in this way, if we are operating on this way, so then again we will get the same result D. So these two function will be equal. If this is the case, then we can say that this O is a linear operator. Okay, so instead of scaling and summing and then operating on O, or instead of operating on the individual this function and then scaling and summing, in the both cases if the result is same, then only we can say the operator itself is a linear operator. So del is, what is this del operator? Del is nothing but the partial derivative, the summation of the partial derivative in the vector form. Okay, we are taking only two component. We can safely add the third component. So we know that this derivative is itself is a linear operator. So if we are taking the derivative of f plus g, so that will be equal to the derivative of f plus derivative of g. So either we will add the function first and then take the derivative, or we can individually take the derivative of both the function and then add. Both the cases we will get the same result. So this del operator is this. So if we first talk about the gradient, so how we can write the linearity properties of this gradient? Okay, so let's say a function f and g. So, or we can say, let's say function a times f, a is b times g. A and b belongs to some scalar, okay, some real number. Okay, so del of this whole function is a times del of f. Okay, so this a and b are just constant, so it will come out of this. Because this why it is going to come out, because this symbol may look different, but this actually is nothing but the derivative. Okay, partial derivative. So it works as a derivative, just it. So in the same way, okay, you can just prove it by expanding this del by del x cap plus del by del y cap. AF plus BG. When you expand this, you can get this result. Okay, I'm just showing it a little bit. Okay, so you can always expand the all function, all this 4 function, and then rearrange, taking the A out because it is a constant. F plus B times no, it's A times del by del y G. No, it is the same x function. Okay, again the A del F y del y cap, and the other one, so this A will come out, and del by del x cap will come out, del by del y will come out, and then F will taken as a factor and will go outside. So this will finally be a del operator F. In a similar way, for the G cases, the same thing will go on, and finally we will get B times del of G, which is this expression. Okay, in the similar way, divergence is also A plus B. Okay, the divergence of A plus B will also will give divergence of A plus divergence of B. If we are taking some scalar A and B, then the A and B will go outside. So we can also prove by expanding this del dot A and del dot B. By expanding this, we can always prove this identity. Similarly, the same things goes with the curl. Del cross A plus B will give A times del cross A plus B times del cross B. Okay, we can expand this this term and this term. Finally, we will get this LHS equal to RHS. Okay, so this is the linearity properties of this del operator. Now there are 6 rules, 2 for a gradient, 2 for divergence, and 2 for curl, that I am going to tell you in the next video, and will give you a little bit idea how to prove that, but I am not going to prove it completely in this video because it is going to be very long. This derivation is quite long, so I am not going to prove it completely. Okay.